formulas. So the second one you guys already know, right? Average, you add the two things and divide by 2. You guys know that from math, which is the mean, right? So this one is intuitive. This is implied, right? So the reason why this one is not on your reference table, like I told you guys, is that physics, they know that you guys have taken algebra and geometry and you had those skills. So this formula is not on your reference table because it's implied. You learned this in math. Questions, anybody? Go away. I can move on. Nice slide yet or no?
Yeah.
Okay, all right, guys. So the second one again now on the bottom is accelerated motion, which is delta V over delta T, right? And the other way, when you rearrange this formula, right, is V final is equal to V initial plus AT. It's the same formula. All they do is rearranging it, right? So constant non-zero acceleration again, right? So these are the formulas. I'm going to pause so you guys can write it down. So whenever you see a question that asks for distance or displacement, these are the formulas that we'll be using. I don't want anybody to sit there like, but Miss Morris, I don't understand.
Miss Morris, can you post this after the meeting?
Yes. I can start explaining it or no? Not yet? Go away.
No.
All right. Gosh, you have to be so defensive. Who's that, Najee?
Definitely was not. It was definitely not.
Who said no a while ago? Oh, that's Madison. Oh, gosh. Gideon said hi.
Hi, Miss Gideon.
So whenever you see a question where they ask for distance, right? That's the formula they want you to use up there. Distance or displacement. What's the difference? One has position, the other one does not. Right? So I have a position or an opinion on, I don't know, passing physics, right? That would be displacement. So I could displace your grades. Get it? No? No? Nobody got it? You get it? And the second formula, right, is VF to find the final velocity. Again, right, is equal to initial velocity squared plus 2AD. A is acceleration, D is your distance. Questions, anybody? So the second formula, notice that there is no time in the formula, right? So if you guys are doing a problem set and they're asking you to find the final velocity and there's no time, I don't want anybody to say, oh, Miss Morris, I don't know which formula to use, right? You're gonna pick a formula based on what you're given and what you're missing. You guys remember the rule of thumb in math? That in order for you to use a formula, you could only have one unknown. If you have more than one unknown, you cannot use that formula. I can change the slide now, guys?
No. Yeah.
Not yet? Okay.
Miss Morris, are you gonna post this on Google Classroom?
Yeah, I'm gonna post it afterwards.
Okay.
Okay? I can change her? Not yet?
You can change it.
Okay. Everybody's good? All right, guys. So an example, right? So I don't know if you guys want to write the example or you want me to go through the example with you guys. What's your preference?
Go through it.
You can
Go through it? Okay.
Yeah.
Starts. I'm sorry?
Yeah, you can go through with it.
Okay. So it says a train starts from rest and leaves the Greenberg station, right? It said it travels for 500 meters with an acceleration of 1.2 meters per second square. What is the train's final speed, right? So what are my two unknowns here? I'm sorry, what did they give me? What are my two givens? They gave me 500 meters and they gave me 1.2 meters per second square. So 1.2 meters per second square, right? That's my acceleration, right? And they also gave me, right, 500 meters, which is my distance, right? So they want me to find my final speed. So in this question, right, I don't know if you guys want to write down for this question, even though they have speed, so in physics, they do that a lot. They're going to use words interchangeably and they're there to trick you. So physics, right? You guys remember I told you guys one of the reasons why scientists make the best lawyers is because, you know, that's what the lawyer try to do. They try to find your weakness and trick you, right? So physics is that subject. They're going to use words, and the word that they use is not necessarily going to be the variable that you're looking for. See how they use speed here, guys? And they're asking you to find what?
The final speed.
Right. You see how they write final speed, but it's inferred that you're finding velocity. So how do I know that they want velocity, right? Because the question says acceleration. And acceleration, right? If I go back, acceleration depended on velocity. Do you see that? So even though the question is asking me for speed, I know in physics that acceleration does not depend on speed, it depends on velocity. So whenever I see a question, right, where they're telling me about acceleration, I know that even though they use speed in the question, they're implying that Miss Morris would know that that means velocity. Everybody understand that? So in this question, I want you to write down where it says final speed, I want you to write, we are finding velocity. And how do we know that again? Because velocity acceleration is the change in velocity. Everybody understand that? So they're gonna do that a lot in physics with you guys. They're gonna try to play tricks with you guys. They want to see if you're mentally alive. Everybody's good at this? So again, right, the formula first, and then we substitute and solve. Notice I have my units. So in math, I know you guys don't have to use units. In physics, if you don't put a unit, you might as well not do anything. So all I do again, so V initial. So even though they did not give me initial velocity here, remember I told you guys that it's implied that you always start off with what number? What is the origin in math?
0.
0. So in this question, they didn't tell you the initial velocity because they're implying, again, because you guys had all this math from all these years, they're not going to tell you that. So in physics, right, the questions, they give you guys a lot of inference in the question. The question is not that easily thought out. You have to spend time thinking about the question, right? So even though they didn't mention initial velocity there, it's implied. So if they're asking you for a final, there must be an initial somewhere. Does that make sense, guys? Easy breezy, beautiful cover girl. So the rest of it, right, you solve. So again, this is PEMDAS. What are you supposed to do first? Square. So you're going to square this number first, then multiply, right? And then you multiply it, and then you will get your final velocity. Again, notice that they have my unit, huh? Yeah. Right. Easy breezy, beautiful cover girl. I don't know if you want to go check the other room to see if the other kids are there. I think they're in 3. No, I don't know if some of these kids is in that room. 335. So you want to go check? I don't know anymore. I don't know. I don't know.
Those kids are the room that was combined.
I don't know, Gideon. I can do physics. I can't figure that out. I'm sorry.
Those two rooms were combined.
Yeah, I can't figure that. Yeah, because yesterday they,
was in 303, 330, and 330.
I don't know, Gideon. I told you I failed that class. Physics, I can't do that.
Yeah, they did.
Everybody's good at this slide? I could change it?
Yeah.
So again, just remember your order of operation, guys. If you add and then multiply, you're gonna get a different number, right? So we're gonna go to the next question, right? So now it says, how long does it take the train to reach this speed? So now we're asking to find what? What's my unknown here?
Time.
Time, there you go. So I'm looking for a formula that has time in it, right? Again, so I have my V final, my V initial. I do have my acceleration, which is 1.2 meters per second square, right? So now all I'm doing is solving for time. So you could do this 2 ways, right? You could use the original formula as it is. If you are mathematically savvy in rearranging a formula, you can rearrange a formula and solve. It's the same thing, whether or not you use the formula as is and solve, or you rearrange a formula, it will be the same thing. What I've found out is that the students actually, they do better if they just plug it into the original formula and solve. If I ask them to rearrange it, sometimes they make mistakes. So if you don't know to rearrange it properly, leave the formula as is and just solve. Right, again, right? So the next thing would be for me to solve, right? PEMDAS. So again, it says 1.2 meters per second square, right? So now notice here that there's meters per second square. Notice that I'm not squaring anything in this formula. Everybody see that? Everybody's good? You see what I'm pointing right here?
Yeah.
So notice that nothing here is squared. So I don't want the students to say, but Miss Morris, why didn't you square 1.2 meters per second here? Because nothing in the formula told me to square anything, right? So I'm going to do A times T, right? So T times 120 would be 1.20 meters per second squared T, right? Then the next thing I'm going to do is divide by 1.20 meters per second squared, 1.2 meters per second squared. I'm going to get 28.8 seconds. Easy breezy, beautiful cover girl. Anybody have any question on this?
No.
Nope.
Okay, so you guys are liking this. I'm jealous. Now, right, so this example is driver traveling at 85 miles per hour, sees a police car hiding in the trees, 2 miles ahead. He applies his brakes, decelerating at negative 500 miles per hour squared. If the speed limit is 55 miles per hour, they want to know, will this person get a ticket? So I know you guys think I'm crazy. Believe it or not, there was a physicist that actually got a ticket, right, from a police officer in California, believe it or not. And he used physics to beat the ticket. He went in there and proved that basically that the police officers what do you call that, the radar gun would be inaccurate based on the specs of that the radar gun, the distance he was, and him trying to determine which car was speeding, and he beat the case. So remember I told you guys, right? I know some students in here want to be lawyers. When you have to go defend a client, you'd be surprised to see how much you have to draw on science to defend your client, right? It's in a criminal case, and you have to talk about DNA, right? Or a paternity case or whatever it is. You'd be surprised to know, some forensic. So you're always gonna have science in there, and I know you guys learned that yesterday when we were talking, when the Brian was talking in the AP research class, right? He was explaining to you guys that even though he's doing research, he's actually patenting one of his ideas. So basically, he's been a businessman. If I discover something, I patent that, I own that. All I have to do is do a business plan and sell that idea. I own it. That's it. I'm good. Right? So I want you guys to be open-minded and not necessarily think that science is in a box. Right? Everything, all the subjects are interrelated. So now that I went on my tangent, right? So does anybody know? What do you think? Do you think this person is going to get a ticket? No? Okay, so let's go to the problem set, right? Again. So we're going to solve for the final velocity, right? So the final velocity based on this formula, VF squared is equal to VI squared plus 2AD, right? So my initial velocity is 85 miles per hour squared, right? My acceleration here is 500 meters per hour squared, right? And they did tell you that the person was driving for 2 miles, which is my distance. Questions, anybody? Now for this question, right, you have to be careful, right? So VI, right? VI is, notice that VI here is squared. Do you guys see that? Do you see VI here is squared? Hello? Anybody out there, guys?
Yes.
Okay, so VI is squared, right? So I'm going to square 85 miles per hour first, right? Then I'm going to multiply this and multiply this. So it's going to be 2 times this number times that number, right? So 4 times 500, 4 5 is 20, this is 2,000. All right, so it's going to be 2,000 plus this 85 squared, which is a number that I can't do in my head right now. Did anybody do that? 85 squared is what? Anybody? Guys,
7,225.
okay, so 7,225, right? Plus 85 squared, right? And now I have to add those together. So it's going to be 7,225 plus 2,000, which would give me 9,223. Now, notice that that's for VF squared. So I have to take the square root of that to find what my final velocity is. So at the end, right, when you get the number, that's gonna be equal to VF squared. So for me to find the final number, and I have to take the square root of that number. Does that make sense, guys? Everybody follow me here or no?
Yes.
Everybody's good? Because if you guys are not responding, I'm not posting this on Google Classroom. I don't want you guys to come here and be lazy, be like, oh, she's gonna put it on Google Classroom, so I don't have to do anything. Nobody's responding, guys.
Okay, Miss Moore. We
We hear
understand.
you.
Nobody's responding to me though. I feel like I'm talking to myself.
But we listening to you.
I know, but nobody's responding. I'm asking a question. I feel like I'm talking to myself.
You gotta give us a second.
I know, but I mean, come on. Can I get an amen? Something.
Amen, Morris.
Amen.
Amen.
You guys are funny. So when I square that, when I take the square root, I should get 72.3 meters per hour. So will the person get a ticket? Yes. Why? Because their final velocity after 2 miles would be 72.3 meters per hour. And that is above the 55 miles per hour.
Okay.
But it's good. Now it says, what would his acceleration be for him not to get a ticket? So here, right, for him not to get a ticket, what speed limit does he have to have?
It will be less than 55.
No, well, not less. He has to be 55 or lower, right? So here you want the final velocity. In this case, the final velocity, right, would be 55. Do you see that, guys? So for the second question, right, for him not to get a ticket, you're going to put the final velocity as 55 miles per hour. So once I'm doing 55, the cop can't touch me, right? So you're going to use the same formula again, right? And now this case, we're going to solve for A. Everybody see that? And the rest of it is algebra. So make sure that when you guys are doing these questions, right, you're getting these numbers. Now, why is it negative? It's negative, again, because of the direction. So in this case, the person is slowing down. Everybody see that?
Yeah.
Yes.
Right? So I don't want you to say, oh, what is negative energy, right? We're going to do questions, and the student's going to get a number that's negative for energy. All negative means, you guys remember in chemistry, I know you guys are trying to forget chemistry, right? But remember in chemistry when delta G was negative, it means it's exothermic. So if it's negative, it means that you're losing. And if it's positive, it means that you're gaining. That's all it means. There's nothing called negative energy, right? So everybody's good at this problem set. I can move on?
Yes.
Okay. All right, guys. Now, so we're going to do an example. So this question, I want you guys to write down, and let me see if you guys could figure out which formula we're using. So write this question down, and let me see if you guys could figure out the formula that we're trying to pick. And whoever figure out the formula, I'll give some bonus points on your assignment. Why not, right? I got to throw something in there. So it says an airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground, right? Determine the distance traveled. So what formula are we using, people? Anybody?
The distance formula?
The distance formula, right? So we're using this formula right here, right? So what did they give us? So let me go back. They gave us acceleration, right? 3.2 meters per second square. So they told me accelerates, but another way that I could check is that the meters per second is to the second is squared. So who's taking calculus in this class?
Me.
You're
Me.
taking calculus? Okay, so I'm going to teach you something easy. This is easier if I teach you through calculus, right? So in calculus, right, anytime you see a unit to the second power, we're telling you that's the second derivative. So this is the second derivative. So basically, right, speed would be your original function. Velocity would be your first derivative, which would be your tangent, right, or your slope. And the second derivative, so the derivative of velocity would be acceleration, which would be your second, which is be a slope of velocity, right? So all the second square, I could tell me that I'm taking two slopes from the original formula. That's all that means. Don't worry, you're gonna see it in your AP calculus exam, right? So we're gonna put down our unknowns again, right? So what happened is we are rearranging the formula, right? So I have VIT plus, right, 1/2 AT squared. Do you guys see 1/2 AT squared as a formula? So the 0.5 is the same as 1/2 in 0.5 is just a decimal, which means the same as 1/2 as a fraction. Everybody get that? Did I lose anybody?
No, we're here.
That is good.
Yeah.
Somebody had a question?
No.
Okay. Again, right? All I do is I do physics, right? I'm sorry, math. So from here, I just have to notice, go back to my original formula. The first thing I have to do is square this number. So I have to do 32.8 squared first, right? then I multiply out, and then I multiply. So 0 times this number. 0 times anything is going to give you what? Knock, knock.
Zero.
Zero.
0. So this whole term right here is going to become 0. So I can ignore this. Everybody see that? So the rest of it is basically going to be this number, right? So it's going to be 32.8 seconds squared times 3.20 times a half. And at the end, I should get distance is equal to 1720. Easy breezy, beautiful cover girl. Does anybody have any question on this? No?
No.
Okay, all right, guys. So we're gonna go to the second question. It says Upton Chuck is riding the giant drop of Great America, right? So you guys like amusement park? So hopefully next year, if there's no coronavirus, right? Every year there's a great thing that they have at Great Adventures. It's called Physics Day for high school students, right? So all the students that go there, like a whole week, is just for physics, right? And you guys basically are able to, from some of the rides, you'll see the formulas, right? And how, the physicists came up with those ideas for those rides. It's physicists that actually derive, come up with these great rides that you guys enjoy, right?
Miss Morris.
Hmm?
Do we get to like ride the roller coasters? And
Of course,
like,
of course.
okay, good. Okay, good.
Yeah.
I think I like Physics
Fun.
Day.
Why would you go there and just do questions? Of course, you're gonna ride the roller coasters.
I'm
That's
just checking.
right. So I said, what would be his final velocity and how far will he fall? So do you guys see that this question is a two-part question? Everybody see that? So first they want the final velocity and then they want to see how far he's gonna fall, right? So what did they give me? They gave me, right? So it tells me that he falls, right? So because he's falling, what did I teach you guys before when I say that when something is falling, the only force acting out of it is what?
Gravity.
Gravity.
And the
So,
gravity, the acceleration is 9.
exactly. So the word free fall here means that. So for this question, sorry, you want the attendance? Okay. So for this question, right, guys, whenever you see free fall, when you're writing this question down, underline those keywords. Write down, see free fall, underline it, put gravity or acceleration due to gravity, right? Make sure I put that little a or little g, right? So I know that directly that I have to put that in the formula, right? Now, gravity here, right? So why is acceleration 9.8? I forget the meters per second square. Why is acceleration 9.8? Anybody know?
Because it was given. I mean, it was given.
Yeah, but why is it negative? Why is it a negative number? Why is it not positive?
Because they were stopping.
Okay,
Well,
everybody's gonna guess?
Because it was, oh, never mind. It's falling, I was going to say.
Okay, it's falling. What direction does gravity pull you?
Down, so it's moving
Down.
back.
So you guys remember in math, right? On the y-axis, and when you go down, remember that was negative y. So that's why acceleration here is negative. Everybody understand that? No, go away, Miss Morris.
Yes, you understand.
Right? Okay. Now they gave me the time, which is 2.6 second. Right? My initial velocity. They didn't tell me the initial velocity, but I told you guys if they don't mention it, it's implied, keyword implied, inferred that it is 0. Yes? So that's where the initial velocity is. So you're not going to find it in the question. So this question have a two-part, right? So when you guys go to college, right, you're taking a freshman physics class. So just like what Brian said yesterday, right, that he said that in the job that he's doing for some of the research that he's doing, he said that if you pass high school physics, right, that's all the content you need to basically do the research. So I just want you guys to understand how powerful my subject is, right? So when you guys go to college and you're doing a question, right, sometimes they'll ask you a question, but you're gonna have to solve, you have to solve something else first and then figure out the other part for you to answer the question, right? So we have D and we have VF, right? So part 1, again, we're gonna go to the original formula. D is equal to VIT plus 1/2, right? 1/2 as a decimal is 0.5 AT squared, right? Sorry, this one I have to, right? So I have to just put it, hold on, let me just change the slides, 1 second. Un segundo, por favor. Okay, there you go. 1 second, guys. I just have to make it smaller because it was not in order. All right. Okay, much better, right? So AT squared, right? Then I substitute. So notice the first thing I do is I put a formula. In physics, if you try to proceed without a formula and you don't have a concept, right, or a theory, I'm telling you that whatever you're saying is wrong. Right? So again, my initial velocity, 0 meters per second, 0 times anything gives me what?
0.
0. So this whole part is going to be 0, right? Now, the number here, because this number is negative, right? And anytime you have a negative times a positive, my answer will be negative in mathematics. You guys remember that? So the distance here is negative 33.1 meters. And all it's saying that it tells me the direction that the person is going. Why does direction matter? Like I said, it matters because, if I go in the wrong direction from my house, right? If I go west, I end up in a different neighbor's yard than if I go east or west or north or south. Does that make sense, guys? So one more thing, I'm going to do a career, what do you call it? A career alignment here. There's this 2 beautiful jobs, right? What do you call it? There's a air traffic controller, which is a beautiful job. We're in Queens. Queens has both airports, right? We're right here next to Kennedy, which is the big international airport, right, of New York. Now, this huge demand, believe it or not, does anybody know or have an idea what the criteria, what are the requirements for you to have the air traffic controller job? Does anybody know? Anybody want to take a guess? Education wise, what do they require from the student, from anybody applying for this job to have minimum education requirements? Hello?
Miss
Hello?
Moore, repeat the question again.
I said, does anybody want to guess what the minimum requirement would be for me to apply for the air traffic controller job at JFK or whatever airport?
Maybe a bachelor's.
Bachelor's, yeah. So believe it or not, right? That is a high requirement. The basic requirement for me to get this job is a high school diploma. All I want is a high school diploma minimum. The issue is though, I have to take a certification exam, and the certification exam is pure physics. So even though it's a high school minimum requirement, most of the applicants have a bachelor's degree because, I could talk for New York City. In New York City, only 1% of New York City public school kids actually get physics. So I want you to find out how lucky you guys are. We're the only school in this building that teaches physics. So what I'm saying is, right, after you take this class, you graduate from high school, if you want to apply for that job, it's a 6-figure job, actually. They paid you 6 figures, minimum $100,000 a year. All they want is a minimum high school diploma, and you have to pass the certification exam. But the certification exam is pure physics. So because of that, a lot of people are, you know what I'm trying to say, right? They end up by default that they can't necessarily apply for it because they can't pass the certification exam. Anyway, guys, anybody have any question about this this solution set? No? So we have one last question to do, right? So part 2, again, right? I'm going to plug in V final is equal to V initial plus AT, right? Again, my V initial is 0, right? Again, here, I'm not squaring anything. All I'm doing is multiplying. My V final is negative 25 meters per second. And again, the negative, all it means is the direction. Everybody's good?
I have a question.
Yes.
Why do you have to do the distance first instead of the velocity?
Why do we have to do the distance first? So here, right? They wanted me to solve for V final. Sorry. They wanted me to solve for V final. Can I get V final here?
No.
Exactly. So for me to find V final, right? So look at this. Look, so the first question I had to solve for D, right? Oh, you mean why do we have to do that before? We could have just did anyone first. It doesn't matter. Sorry. So for this, in this question, it doesn't matter. You could do this first and then do the other one. It doesn't matter. Because we're not plugging in. See, if we go back, right? We're not plugging distance into the second formula. Do you guys see that? So good question, Madison. Everybody see that or no? Hello?
Yeah.
Hello, anybody?
Yes.
Yeah.
All right,
Yes.
guys. So one last question, right? So it says the feathers dropped on the moon from a height of 1.4 meters. The acceleration of gravity on the moon. So why are they giving you gravity here? Because every planet has its own gravity, right? So the acceleration on the moon is 1.67 meters per second square. So the reason why they gave you acceleration here is because we're on Earth, and everything on Earth is going to have the same acceleration due to gravity because we're on Earth. So if you're going to a different heavenly body, right? If you go to Pluto, Mars, they're going to have to give you the acceleration. So they want you to determine the time for the feather to fall to the surface of the moon, right? So what did they give us, right? They gave us my V initial. Again, V initial is implied. They're not going to put it in the question, right? They gave me my distance and they gave me my acceleration. Again, acceleration, because it's dropped, it's negative. Questions, anybody? No? Nobody's talking to me. Hello, guys.
No, Miss Morris.
Okay, right? So they want you to find T right now. So I go back into my formula, right? Let me just change this one because I think, second, this one is a little crazy here. Right? So that's what it's supposed to be. Nope, sorry, 1 second. I'm trying to fix it. It's not aligned properly. Okay, there you go. All right, so slideshow from current. Okay, now, right, so my formula, right? VIT plus 1/2 AT squared, right? My distance here is negative 1.4 meters, right? Again, anything times 0 is gonna, so this whole thing right here is gonna be equal to 0, so I could drop this from the formula. So sometimes, right, you're gonna see this formula, and they're gonna put D is equal to 1/2 AT squared. Whenever they do that, they're either saying that the initial velocity is 0, right, or time is 0. Because anytime one of these numbers is 0, right, 0 times anything, this whole thing is gonna drop out. Everybody see that? Hello?
Yeah.
Yes, Miss
Yes.
Morris.
All right, guys, again, right? So again, we just plug it in, right? So here again, remember that we're solving for T squared, right? So you multiply out, we're gonna get 0.835 meters per second squared times T squared, right? 0 times plus anything gives me the same number. So what I'm gonna get at the end is that T squared is equal to, so all I'm doing, right, is taking this part and I have to bring it over to over here, right? So I'm gonna divide. Everybody see that? Because here, right, do you see that A is multiplied by T here? Everybody see that? So for me to solve, right, I'm gonna have to divide because here the order of operation is implied that is multiplication. So if I wanna get rid of it, I just divide. So I'm dividing by 0.835 on both sides, right? Which is gonna be equal to T squared. Now, when I get that number is T squared. I have to take the square root of this number to figure out what T is. You have to remember that one part. Questions, anybody?
No.
No? Everybody's good? So if I give you guys a problem set tomorrow, 4 questions, you should be able to solve them, right? Showing your work.
Don't play.
All right, guys, so what's my solution steps? Don't skip any steps. For the student in math and in physics that skip a step, you're going to fall. You will not know what you did wrong. Everybody see that? Right? Construct an informative diagram. Identify the list of given, right? Put the variables, identify the list of unknown like we did before, right? Identify the equation that you're going to be choosing from. Substitute. Last thing, check your answers. In physics, please double check your answers because you might have had a potential error. So that question that we just did, right? Remember they asked you for T and the formula solved for T squared, right? So if you go back to that question, right? If you stopped here, you'd have gave me 1.68 seconds squared. But this number is for T squared. I wanted T. Everybody see that? So you have to double check your answers. So that's it, guys. I have nothing further to teach.